Okay, so this is the beginning. We're going to talk about the first chapter of the Business Intelligence Guidebook. Um, and uh, I said this is a lot about data, but it's not just data. We need data integration to unify and transform data. So data comes from disparate sources, and we need to bring it together. We need data warehousing to store and stage it, although that has changed somewhat with new technologies available. And we need some way to present it to the decision makers in an understandable way. And lately, the catch-all for that has largely been business intelligence, which kind of brings to mind that you're kind of like spying intelligence, except you're not really spying to do it. You're looking at the data. Um, So the raw data needs integration, design, modeling, architecture to transform it into useful information. And so data is generally considered to be raw facts. And if you organize it to some extent, then it becomes information. And perhaps you might organize information to produce knowledge. And I don't know if you'd ever in computer science get to wisdom, but that could be a higher level. And the idea that drives a lot of data-oriented computer science is society produces huge amounts of data, and it's a potentially valuable resource, but you could be easily buried under that large amount of data. The book calls it, the Business Intelligence Guidebook calls it the data deluge. Uh, and most of it's pretty fine-grained and not very meaningful. There's a real possibility of being buried and not having any idea what to do with it. And so the first step is to organize it into something, trying to organize it into something meaningful. Some key themes that show up in the chapter. Data is valuable. It helps make better decisions. I take that as a given, but there's a little bit of discussion there. There's no silver bullet that vendors make it seem easy. You can't avoid the hard work, though, and there's some discussion of that in the book. Uh, what kind of data is interesting? And the answer is really all kinds of data. So, and I should say this up front. I'm not quite upfront enough. I'll always talk about businesses, almost always, but other organizations can make use of a lot of the same stuff. If you're a nonprofit, then you're less worried about profits. Well, not worried about profits. So maybe you're less worried about bringing money in, but maybe you aren't. Uh, but you're certainly interested in costs. So in a normal business, some of the data that might be interesting might be information about customers, prospects, potential customers, suppliers, any kind of partners that you have, employees, different kinds of employees, transactions, be they sales, orders, whatever, internal processes such as manufacturing, warehousing, shipping, billing, perhaps competitors, perhaps outside factors, weather, the economy, whatever, et cetera, et cetera, et cetera. A lot of different things you could be interested in. We should talk a little bit about the perhaps misnamed big data. To qualify as big data, it needs to be more than just big. Although, yes, one of the criteria is volume, that it is big. And some of the things that have changed that have led to bigger data is, say, capturing click streams on websites. If you're running a website, you might find it interesting to capture every click that happened on your website. Uh, you might have sensors. There's a whole emerging field of Internet of Things, and there's also RFID, and there's sensors that are available. And there's surveillance cameras, so images could be interesting. Not just images, but actually video could be interesting. And then there's also text type things, web postings, social media, reviews like on Yelp and uh, various other uh, advising sites. And that leads us to variety, that it's not just structured. You can have structured, semi-structured, unstructured. Structured data has rows and columns, but now in big data we can have text, audio, video, and so forth. And velocity, um, it's not just big, but it's accumulating faster than ever before. And in many cases also needing action faster. So in some cases, decision support is more rather decision making, where the program actually makes a decision on the fly. One of the adjuncts in our program, Rob McGinley, has worked where they're doing systems that decide in a split second whether to bid on putting an ad for their client on your feed, say in a, a website or a social media site. And that has to be an instantaneous decision because they don't wait around for 5 minutes to take bids to decide who's going to get the ad that shows up on the side of your screen. Okay. Um, so now a slight transition here. So we're going to talk about the contrast between transactional and analytical. And I didn't fill it in, but mostly this is about transactional versus analytical databases. So when in transaction processing, doing operational day-to-day operations such as handling bank deposits, handling store purchases, orders, reservations, the database has to handle all, the acronym people frequently use is CRUD, create for insert a new row, read for see something that's already there, update for change, and delete for deleting a row. And we might only keep data for a limited amount of time. People don't call about their orders 3 years later, so old data can be archived to cheaper storage. I should have said on the previous, so database designs then are optimized typically for inserts and updates. Okay, we might have different systems for different parts of a business or organization. So for instance, different divisions, which might be divided regionally or by countries, or might be divided other ways. We might have product divisions, and they might have separate systems for different, product lines. And then we also might have different systems for different functional areas: marketing, sales, manufacturing, warehousing, shipping, billing. It's really common for these systems to not interact, and sometimes these are referred to as silos or stovepipes. Either one gives the impression of something going straight up. A silo would be like a farm silo. A stovepipe is like a smokestack. And so the analogy there is that the information coming out of them are independent of each other. They don't come together. And so then that's a challenge for doing analysis. Also, a challenge for doing analysis on a transactional system is that the systems may be too busy handling day-to-day activity to do a good job of doing heavy analysis. In contrast, an analytical system with an analytical database, the database has to excel at read rather than all of CRUD. Because updates are frequently done in a batch, so you're not having constant second-to-second updates necessarily, whereas all the analysis is doing reads. Interesting analysis may involve trends over time. So 5 years of data could be interesting, whereas the transactional system might not have 5 years of data on easily accessible storage. We want to be able to pull together analysis involving different source systems. So if we have a separate marketing and a separate sales system, we want to know how marketing did by finding out what sales it generated. We might want to pull together analysis for different regions to see, so we can compare how the different regions are doing to each other. And we want fast response for unanticipated queries without slowing down the day-to-day transactions. And so you'd like to not just provide standard reports, but to give people flexibility as to what they can ask about. An analytical database might bring in outside data that the transactional system doesn't care about. So if weather matters, we might want to bring that in so we can see if there's impacts or what the impacts are with weather with whatever else we're looking at. Same could apply for the economy. In some cases, we might want to bring in customer sentiment from, say, social media or websites that could be talking about our products. And we might provide analysis that's not really needed in the source. A lot of companies have what are known as key performance indicators that they like to measure, or they might have an analysis that gives a value for how much a customer is worth. Now, actually, a number of companies feed back that if it's calculated in the analytical system to the transactional system, you might actually find that when you call somebody for customer service, and you might never know this, but you might be prioritized instead of, as they say, be taken care of in the order that the call arrived. Okay, so we're going to be concerned about data quality. And so some things that we might look at for data quality is that it's clean. Real data has missing values, invalid values. Kimball, again, the data warehousing expert, says data quality is always an issue. And he's not just a textbook author, he became a textbook author from having a consulting firm. He says customer and prospect data is notorious for being dirty. We also look for consistency. So if we have different systems that include the same thing something with the same name, it might be calculated differently. So for instance, if we're doing across regions, we have one system that's in Europe, one system in the US, they might have different fiscal years, or different parts of the organization might have a different way of looking at revenue or profits. Surprisingly, that can vary. Conformed, we'll talk about at length when we go to modeling later, but we like common shareable dimensions. So if one part of the system has customers, we want customers to be the same data from one place to another. We want it to be current for the task that we're trying to perform, and we want it to be comprehensive, complete. There's some talk in here about data governance, and the key thing here is this is talking about control of the data, making sure that everything's right. And so we want to try to avoid things being measured different ways. And that might be different data definitions, it might be different calculations for the same metric, for the same measurement. And this is important for auditing too. Auditing has become more important in recent years. Data integration is going to be a very important topic in this class. I think we'll spend a couple weeks on it. It's the most underestimated task in data warehousing. Most people who do a project say it took a lot longer than they expected. It involves not only gathering data from different sources, cleaning it, standardizing it, so if there's differences in definitions, transforming it, we might need to do calculations or code lookups, and conforming the dimensions as we talked about. It's worth talking about the danger of spreadsheets. There's no quality control. If an individual puts in an incorrect formula, there's no check on that. It's unlikely that it'll be caught. There's also an issue with version control. If you pass around a spreadsheet, it could, as we say in computer science, it could fork That's from public open source coding lingo. But the idea is that I have a copy, I send it to you, you make a change to it. Now we have two versions of the same thing, and they don't necessarily agree with each other. And if you pass it along to somebody else, then that somebody else could change it, and then you have a whole reconciliation issue. It's also spreadsheets don't get shared to necessarily everybody who can benefit from them, and there's no automatic update. So if new data should be put in, it's not necessarily integrated and brought in. Um, Looking big picture, um, this kind of divides it up, a project into uh, integration, data warehousing, business intelligence. Um, I think I've mentioned Bill Inman. Bill Inman is the other big data warehousing expert. His definition of data warehousing is it's integrated, so data is gathered and made consistent from one or more source systems. It's subject oriented, it's organized by data subject rather than by application. It's time variant, meaning historic data can be stored, and it's non-volatile. It doesn't tend to get modified. It tends to be read and calculated and so forth. Okay, towards the end of the chapter, there's uh, some talk of terminology, and I will do some of the terminology, but I won't do all of the terminology. Some of this you don't need to know for a while. Uh, and so I'm going to focus, I got 3 slides following this. You'll notice that on the right, there's a number of different types of things that can be considered part of business intelligence, although some people would consider the big title here, analysis or analytics, and business intelligence to be one of the topics under here. But business intelligence tools seem to be getting broader and broader and handling more and more of the capabilities. Likewise, under data integration, several of those are types of tools that are available. And under data warehousing, most of those are types of storage. Okay, so let's see. So I'm going to focus on some of these things here. Some of them well, one is like analytics is obvious. We already talked about it. But let's talk about some of these things. So ad hoc query, you get an answer from a database when the need arrives, where the need may not have been anticipated. SQL was designed to provide ad hoc queries, and a lot of BI is in essence providing ad hoc queries. Let's see, let's go down to dashboards. Display, a lot of times graphical information, they might display several pieces of information on one screen so that you could get a quick big picture look at how things are going. A lot of the times these are created for high level executives. And when at some point, I'll show you example dashboards. Data visualization is a general thing of presenting data in a visual way with graphs and charts. They help make points quickly. And dashboards frequently use data visualization. And there's a common pitch these days for what's known as self-service BI that also tends to make use of data visualization. I'm going to skip down to OLAP, which stands for Online Analytical Processing. It's kind of like a multi-dimensional pivot table, if you know pivot tables from Excel. And so you can show something by something, and then maybe you can put something underneath it and have, say, product sales by region and within region country. And you can also drill down from, say, by seeing sales by state to seeing sales by city within that state. The traditional way of doing OLAP was the data was in cubes, which were considered multi-dimensional databases. but that's kind of mostly obsolete now. Other databases have gotten fast enough that you don't really need the cubes. Operational BI is the use of BI tools on operational data itself as opposed to a data warehouse. Predictive analytics, where we predict the outcome or trends based on the data that we have. And this can be done different ways, including via statistics and via data mining. Reporting is kind of standardized reports. So we have tables of information. Traditionally, reports were static and predefined formats. And so you'd have a report and it would show the same thing every time, just with the latest data. Now a lot of reporting is done with better tools and it's more interactive and customizable. Scorecards are for performance management. It helps managers track performance against strategic goals. These may be presented in a dashboard or they could be represented in tables. Self-service BI is tools that allow business people to obtain the information they need without the help of the IT group. So they have a tool, they have data, they go to it, they decide how to display the data. In some sense, this is a mirage because behind the scenes, IT group still needs to prepare the data, make it quality data. Otherwise, you're going to get garbage in, garbage out. Finally, for this page, text analytics is the use of data mining for analysis of unstructured textual data such as emails, social media posts, and so forth. Let's see, for data warehousing, I am going to talk about data marts, which are a subset of a data warehouse that's usually oriented towards a business group or process rather than the entire enterprise. These are controversial because sometimes these weren't actually subsets of the data warehouse, but were rather silos of information with their own data definition, their own calculations that didn't come together with allowing you to integrate information from different sources. Because of the controversy, Kimball no longer uses this term. Inman used to beat him up on it. And Kimball said, no, you're saying data marts to mean something different than I'm saying. And so you're criticizing them based on what you say they are. Probably shouldn't, I don't know why they have data quality here. Probably doesn't need to be defined. We already did it. The 5 C's is one way of looking at that. And I don't know that we need to talk about data preparation. That's the whole thing of data integration and preparation. But it is worth talking about ETL, which stands for extract, transform, load. Part of the data integration process, data is taken from a source system, which is extracting. It's processed, which is transforming. And this will be a large topic in our data integration section. And stored in a data warehouse or database, loaded into the database. ETL tools are a big area. Automating data integration tasks. Most of the ETL tools now refer to themselves as data integration tools. Some organizations wrote custom code instead of using big expensive ETL tools. More recently, a number of people have swapped the T and L and used ELT, where the transformations happen after loading. I guess it's worth mentioning operational data stores, which was a creation of Inman, which may serve both operational and analytical purposes. Let's see. So now in the data integration side, gosh, there's a lot here, and we're already running pretty long. So data cleansing is finding and fixing errors or inconsistencies. Data integration tools provide commonly needed capabilities for that, but there are dedicated data quality tools that exist with additional more complex capabilities. and also custom code can be used. Data profiling I put here rather than under BI. And the idea, and we'll talk about this in data integration, is examining source system data for problems in values, frequencies, relationships. So you're trying to find data problems. So if I had student data and I did a SQL query, say, and a lot of times this is done with SQL queries, and I did a quick SQL query to find the max GPA of any student, and I found a max GPA greater than 4.0, well, that would be a problem. Besides just running some SQL queries, there are dedicated data profiling tools that can provide this. Let's see, data governance we talked a little bit about before. Um, I think given the time, I'm going to leave it for now. Dimensional modeling will be a major topic for us. I probably would have put it under data warehousing, but you do have to have a model as part of data integration. This is data modeling designed for analysis. And so the data is structured to support analysis rather than updates. This is a generally accepted idea. It's in sharp contrast with third normal form modeling in transactional systems. A lot of times, someone who has a strong background in database design with third normal form has a tough time dealing with this. We also list ETL here, but we discussed that on the previous slide. Master data management is where you try to maintain a consistent view of key data. So things like customers, suppliers, employees. We might go to a lot of work to standardize these, including how do you talk about groups of customers? And so it could be by region, and then within region, it could be state, and within state, it could be maybe a smaller territory. That kind of forms a hierarchy, and we probably want to have the same hierarchy across everything we do rather than having incompatibilities. Metadata management. So metadata is data about the data. In managing metadata, an enterprise needs to understand what the data means, how it was transformed from creation to consumption, and even its data quality. And I would say this is part of data governance. Okay, and at the bottom we have structured data and unstructured data, which he kind of already covered. Structured data is typically in rows and columns, although there are hierarchical structures. And unstructured data can be free-form text, emails, tweets, but it can also be images and video. That's the end of chapter 1. I was going to bring in, this is like a how-to chart, kind of a flow chart of how to do a data warehousing project from Kimball. But given we're 28 minutes in, you only have a certain amount of attention span. It's only a certain amount of time. I'm going to leave it here. You can look at it, but I'll maybe discuss it another time.